AI is everywhere. It's in your phone. It's in your walls. It's even in a toothbrush for some reason. So what better way to chase clout than smash two already existing videos together? So yeah, we're gonna have ChatGPT make a game, and then we're gonna make an AI that can learn how to play ChatGPT's game. First, we need a game idea, so I'm gonna have ChatGPT come up with a few to choose from. Alright, so for the first game, we have Dodger. Player moves left and right to avoid objects. Very original. By the way, the quality may look bad, but that's just because I had the wrong settings in my recording software. It'll get better next video, so yeah. I read through the other ones, and I think I am gonna go with Dodger, even though I was joking about it, because I'm gonna be training the AIs through basically an evolution simulator, and honestly, I think this one would be the coolest to watch, so... I'm making an evolution simulator instead of what most AI uses, which is backpropagation, because I'm pretty sure that uses calculus, and calculus kind of scares me. So, GPT, what should our game's theme be?
Hey, that rhymed!
Meteor shower? Okay. Before making the game, I'm gonna generate some images for sprites, and I don't really know an image generator, so let's just use a random one. Editor dannium here. I've been procrastinating. This was recorded like 6 months ago, so somehow I didn't know that ChatGPT could make images, even though it's right here in the video, but yeah, just ignore that. Alright, so these images are kind of trash, so I'm gonna go to a different generator. Alright, these images are kind of trash. Yeah, I ended up going to 4 generators. But at least we have our 3 images. Anyways, let's make a new Unity project and import the sprites and copy paste some AI code. Bro, it's in 3D. And clarify the game is in 2D and copy paste some AI code and copy paste some more AI code. And now we have a game made by AI. So now we gotta code an AI to play the game. Alright, note to self, insert the montage right here.
Non-copyrighted. Non-copyrighted. Oh my god. Non-copyrighted montage music. Oh my god. Montage is non-copyrighted. Montage royalty free. Non-copyrighted. Non-copyrighted. Oh my god. Non-copyrighted montage music. Oh my god. Montage is non-copyrighted. Montage royalty free.
After a bunch of errors, I got the AI to move, which is a step in the right direction, but first, what am I even trying to code? This is a neural network. It's used for most AIs, and it's not as complex as it looks. Neural networks are split into layers. The input layer, so values like a rocket's position or its distance from an asteroid. A bunch of hidden layers where most of the calculations happen. Then an output layer, which gives us how much the bot should move. The circles are neurons, which hold values, and the lines are weights, which are values tuned to determine the output. For each neuron, all the neurons in the previous layer are connected with a weight. Then we multiply each neuron by the weight. We add all them up, we squash them down between -1 and 1, and then we do this for every single neuron, every single frame. And now we have an AI. Hey man, I don't think it's working. Yeah, so right now we have random weights, meaning that it'll just do random stuff when given different inputs. So what we're gonna do is train the bots to avoid the asteroids somehow. Backpropagation is the most used method, which somehow makes the weights better based on an expected output or something, but again, I'm scared of calculus, so I'm gonna do an evolution simulator type thing. Basically how it works, each bot has a score. It goes up for stuff like surviving longer or staying closer to the middle. At the end, the top 50% of bots have children with slightly mutated weights, and them and their child move on to the next generation, while the other 50%, that's not important. Alright, so first test. Not sure why it's so laggy or why they don't move that far, and they don't know what a wall is, and children aren't being made correctly, but it's fine. And honestly, some of them can already avoid asteroids. But since I have a lot of errors to fix, I decided to add a speed bar. Now I can control the speed of my non-functioning game. Anyways, I fixed my code by just writing this thing. And I also added a generation count, so now we can watch the simulation running, and it's pretty cool. The main problem right now is the giant lag spikes, and oh no, my PC! I added average and best counters to see how good they get, and after 200 generations, the average only increases by about 20 seconds, which isn't awful, but definitely could be better. Anyways, I found out that the lag spikes were caused by using polygons for all the colliders instead of simpler shapes. So Unity had a hard time deleting and recreating like 100 different complex shapes in a single frame, so yeah, now we have much simpler shapes. Anyways, I was in denial that my code wasn't working good, so I added a recent average thinking that the average wasn't getting better because there were a lot of generations. Yeah, that did nothing. At this point, I was coping so hard that I thought that the asteroids were too random for an AI to learn to avoid them. Looking back, I don't really know how I thought this, because most AI deal with random stuff like this, so if my code was good, the bots wouldn't be capping at 1 minute. To fix my problem, I simplified the game, seeing how long they could last only being able to go in one direction, having to go as slow as possible. They started at 1 second, but they couldn't get better than 60 even after 500 generations. So I looked through my code, and after honestly a pretty sad amount of time, I figured out the error. The way I mutated them, 3% of the child's weights, which basically represent genes, would be set completely randomly. So even if the parent's genes were 100% perfect, the child would only have around 97% of the good genes. So now for a child's genes, there's a 1% chance to completely be random, a 1% chance to add or subtract a random number, and a 1% chance to multiply the weight by a random number. And now, instead of taking 60 seconds after 500 generations, it takes 11.5 hours after 88 generations. That means that our AI got over 600 times better. So I put the normal settings back on, and let's let it train. I'll be right back. Oh, but before I go, I realized that 1% of the child's genes are still completely random, so I'm not sure why it works so much better. It could be because the majority of the mutated genes are not completely random, but maybe comment below why you think that is. Alright, it's been training sped up for a couple hours now. We started at 40 and over 1,500. That is not bad at all. You can definitely see them going towards the middle, and that's because I made them lose points for going too far away. And the reason I did this is so that they don't hit the border and die. They also seem to favor going left, and I honestly have no idea why. I put the game on itch.io, so you can go check it out. Click here to see my past works that I'm not proud of. Smash like if you like, dislike if you dislike. I hate Tuesdays, and leave now, the AI is coming out of your walls.